Good evening, class. Here's chapter 3, functions, section 3.1, functions and function notation. So in this chapter, we are going to look at section 3.1, functions and function notation, 3.2, domain and range, 3.3, rates of change and behavior of graphs, 3.4, composition of functions, 3.5, transformation of functions, 3.6, absolute value functions, 3.7, inverse functions. Here's the objectives for this first section, 3.1. Determine whether a relation represents a function, find the difference quotient of a function, determine whether a function is one-to-one, use the vertical line test to identify functions, graph the functions listed in the library of functions. So reminding you of the distance formula, d is equal to square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, and the midpoint is x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. In the case of a proportion, a over b equals c over d, the cross product ad equals bc. This is going to be very important in this chapter. So reminding you of the slope, rise over run, change in y over change in x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Lines, standard form ax plus by equals c, slope intercept form y equals mx plus b, point slope, y minus y1 equals m times x minus x sub 1. Vertical lines, equation x equals a, m is undefined, x intercept located at a0. Horizontal lines, equation y equals b, slope is 0, m equal to 0, y intercept is at 0, b. Two lines are parallel if they have equal slopes, different y-intercepts, they are perpendicular if the product of their slopes is -1, or simply m1 times m2 equals -1, or m2 equals -1 over m1. A complex number has a standard form of a plus bi. Its conjugate is a minus bi. The imaginary unit I is square root of -1, and square root of -n is I times square root of n. Therefore, I squared is -1, I cubed is -I, and I to the power of 4 equals 1. Standard form of a quadratic equation is ax squared plus bx plus c equal to 0, where a is not 0, and b squared minus 4ac is known as the discriminant. So x equals minus b plus minus the square root of b squared minus 4ac over 2a is the quadratic formula, the solution to that equation. And it plays a huge role, this part known as b squared minus 4ac, or the discriminant. When it's positive, you have two distinct real solutions. The solutions will be rational if the discriminant is a perfect square, and irrational otherwise. If it's 0, we have one real solution. And if it's negative, we have no real solutions or two complex solutions. What you're looking at here are exponential rules that we have seen before. A linear inequality in one variable is an inequality that can be written in the form of ax plus b less than c, or less than or equal to c, or larger than c, or larger than or equal to c. Needless to say, a, b, and c are just some real numbers, and a can't be 0. In the case of an absolute value, which represents distance from 0, the absolute value principle for equations, for any positive number k and any algebraic expression x, the absolute value of x equals k satisfies that x equals negative k or positive k. If absolute value of x is 0, x is 0. And if absolute value of x is minus k, it has no solutions. If absolute value of x is less than a, and a is positive, then x is sandwiched between negative and positive a. And if a is negative, less than 0, there is no solution. If absolute value of x larger than a, and a is larger than 0, then x is either less than minus a or larger than a. And if A is negative, then the solution set will be all real numbers. Some of the identities we remember: A plus B quantity squared is A squared plus 2AB plus B squared. A minus B squared is A squared minus 2AB plus B squared. A plus B times A minus B is A squared minus B squared. And now let's start with 3.1, functions and function notation. Dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. Relation. A set of ordered pairs. Domain. The set of all input values, meaning the x values or independent variable for a relation. Range. The set of all output values, meaning y values or dependent variable for a relation. As we look at a graph, all the values that it covers along the x-axis is known as the domain. All the values that it covers along the y-axis is called the range. Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range. In other words, the x coordinates do not repeat. The graph of a function or relation is the graph of its set of ordered pairs. As we look at these two cases, the first one represents a function because the x coordinate, the first coordinate, in this case Tom, Bob, Mark, Bill, they do not repeat. So if we were to write this, we would write Tom, comma 21, Bob, comma 22, Mark, comma 25, Bill, comma 20. This represents a function. However, if you look at this one, Tom, comma 21, Tom, comma 22, since Tom repeats, this fails to be a function. So this is not a function. Tom can't be 21 and 22 at the same time. Determine whether each relation represents a function. If it is a function, state the domain and range. So as we read part A, 2, 3, 4, 1, 3, negative 2, 2, negative 1, we notice that this one repeats. Therefore, it fails to be a function. No, it is not a function. The element 2 is assigned to both 3 and negative 1. What about this one? Basically, you look at the x coordinates to make sure they are not repeating. So this is minus 2, 3, 4, 1, 3, negative 2, 2, negative 1. So you look at the first element, the x coordinates, negative 2, 4, 3, 2, they are not repeating. Therefore, it does represent a function. So yes, it is a function because no ordered pairs have the same first element and different second elements. So what is the domain? Well, the domain would be minus 2, 4, 3, 2. What about the range? The range would be 3, 1, -2, -1. Okay. So again, pretty straightforward. The domain, -2, 4, 3, 2. The first coordinates, the range 3, 1, -2, -1. The last coordinates, the second coordinates. There's a comma here. What about the last one? Notice the first elements are 4, 3, 4, 2. So since 4 repeats, this is not a function. So no, it is not a function. The element 4 is assigned to both 3 and -3. That fails to be a function. Determine if the equation defines y as a function of x, where y is given as -1/2 x. This does represent a function. Yes, this is a function, since for any input x, when you multiply by -1/2 and then subtract 3, you would only get one output, y. Now, to generalize this, I want you to recognize this as what we call a linear function. It's a polynomial of degree 1. Every linear function represents a function. So linear function. X equals y squared plus 1. So the best course of action is to solve for y. So I can move the 1 to the other side, so y squared becomes x minus 1. And therefore y is plus minus square root of x minus 1. And this practically gives it away that this is not a function. No, this is not a function, since for values of x greater than 1, you would have 2 outputs for y. So again, no, this is not a function, since for values of x greater than 1, you would have 2 outputs for y. So if you pick, for example, number 5, 5 minus 1 gives you 4. The square root of that plus minus gives you plus minus square root of 4, which is plus minus 2. So just a quick example. If I, for example, pick x equals 5, I get plus minus square root of 5 minus 1, which is plus minus square root of 4 or 2. What about x squared plus y squared equals 1? We do the same thing. We solve for y squared. We get 1 minus x squared. And again, y is plus minus the square root of 1 minus x squared. It fails because of this plus minus, just like this one. It fails to be a function. So no, for values of x, specifically between -1 and 1, 2 values of y, result. And then when x is 0, y, for example, as an example, if you choose x to be 0, is plus minus 1. By the way, the reason x is between -1 and 1, you can work on this because you're dealing with the square root. 1 minus x squared must be greater than or equal to 0. And this can be shown by the sign graph that makes x between -1 and 1. Find the value of a function f of x equals 2x squared minus 3x for all of these cases, starting with part A, f of 3. Just plug in 3 into this. So this is 9. 2 times 9, 18, minus 9 is 9. F of x plus 3, so write plus f of 3, write this one, plus f of 3, we've already calculated it. We don't have to go through the process again. We know this is 9. So write this one plus 9. And now drop the parentheses. The answer is 2x squared minus 3x plus 9. Part C, 3 times f of x. So 3 times f of x, which is 2x squared minus 3x. Distribute the 3 and you get 6x squared minus 9x. The next one is f of minus x. So simply put, in this case, replace the x with minus x. As you know, minus x to the second power is still x squared. So this is x squared, 2 times that. So let me write this at top of that. So this is x squared, everybody. And 2 times that is 2x squared. Negative and negative, they give us positive 3x. The next one is minus f of x. To get minus f of x, put a negative in front of the expression and distribute, you get minus 2x squared plus 3x. F of 3x. Wherever you see x for f of 3x, replace it with 3x. So you get 2 times 3x quantity squared minus 3 times 3x. So take a look at this one. F of 3x means replace each x with 3x. So this one becomes 3x to the second power, and this one just changes to 3x. As you know, this is 9x squared. With the 2, the product is 18x squared, and these 2 minus 9x. The last one is asking for f of x plus 3. F of x plus 3, that means in this expression, replace the x with x plus 3. So it becomes 2 times x plus 3 squared minus 3 times x plus 3. We are going to square this. We get, let me remind you of a plus b squared is a squared plus 2ab plus b squared. Therefore, this is x squared plus 2 times the first times the last one, 6x. plus the last one squared 9. This one you just distribute, you get minus 3x minus 9. So we have 2x squared plus 12x plus 18 minus 3x minus 9. So 2x squared remains, 12x and minus 3x are like terms. They add up to 9x, and then 18 and negative 9, they add up to positive 9. Therefore, f of x plus 3 ends up being 2x squared plus 9x plus 9. Find the difference quotient, sometimes we just call it dq, of a function which has the expression f of x plus h minus f of x over h, where h can't be 0. For the function f defined by f of x equals minus 3x squared plus 2x, evaluate the dq. So to do this, replace the x with x plus h, and you get minus 3 times x plus h, quantity squared plus 2 times x plus h, minus f of x, just plug it in, just the way it is, over h. This plays a huge part later on in math and calculus. So we are going to simplify this by raising this to the second power. This is x squared plus 2xh plus h squared. We are going to distribute the negative 3, okay? And of course, this is 2 times x plus h, or 2x plus 2h. And this is going to be plus 3x squared minus 2x. So we have this one here. Let's distribute the negative 3, resulting in negative 3x squared, negative 6xh, negative 3h squared, and let's add up like terms. So let me use different colors here. Negative 3x squared, positive 3x squared cancel each other. 2x, negative 2x cancel each other. So what we see in the numerator is negative 6xh minus 3h squared plus 2h. So this piece, and this piece. There are 3 terms, and each one contains an h. So we are going to factor the h out from those 3 left in the numerator. When you factor the h out, this gives you negative 6x, this gives you negative 3h, and this gives you positive 2. H and h cancel each other, and you're left with the parentheses minus 6x minus 3h plus 2. Example 5, for the function f defined by f of x equals 2x squared minus 3x, evaluate the dq f of x plus h minus f of x over h. So we want to evaluate this. We do the same thing as before. We're going to write 2 times x plus h squared minus 3 times x plus h. This is this one. Minus, just write this unchanged, minus this expression 2x squared minus 3x, and the denominator is not changing. We need to raise this to the second power, becomes x squared plus 2xh plus h squared as we've seen it. We have to distribute the negative, we get negative 3x minus 3h. And we need to distribute the negative sign, minus 2x squared plus 3x. We are going to distribute number 2, we get 2x squared plus 4xh plus 2h squared. And now we are going to combine everything by combining like terms. We end up with the following. These two cancel each other. These two cancel each other. What is left? 4xh plus 2h squared minus 3h. Again, we can factor out the h from the numerator. The denominator repeats. So when you take the h out, this gives you 4x, this gives you 2h, and this gives you minus 3. This h cancels out this h. And we are left with the parentheses 4x plus 2h minus 3 as the final answer. Evaluation of this expression becomes extremely important later on, so you want to be very comfortable with that. We're going to continue with this example. F of x is 4 over x. And we're going to evaluate the dq, or the difference quotient. So f of x plus h minus f of x over h. Notice f of x is simply whatever you have here. H doesn't change. It really, you have to evaluate this one. And in this case, becomes 4 over x plus h. To simplify this is a complex fraction. The best course of action is to multiply and divide by LCD. There are two fractions in the numerator. The product of x and x plus h is the LCD. We're going to multiply and divide by. When we do that, the denominator remains as a product of h and x plus h. What happens to the numerator? It simplifies it as follows. We're going to multiply these two. I'm going to multiply this one by this one. The denominator goes away because x plus h cancels out x plus h, and it becomes 4x. So please understand, the product of these two, x plus h goes away, 4x. The product of these two, now x goes away, minus 4 times x plus h. So again, times the first one, 4 times x plus h, 4 times x, and this one minus 4 times x plus h. Minus 4 times x plus h gives you minus 4x minus 4h. I can write that for you if you want. So the product of the second part is minus of 4 times x plus h, which gives you what you see here. And these two cancel each other. So we end up with negative 4h in the numerator. This whole thing changes to negative 4h. We can cancel out the h from here and here. And the result is minus 4 over x times x plus h. That is the final answer, everybody. How about f of x is square root of x? Well, we want to evaluate it in this expression. So this part and this part is very obvious. This is just square root of x. So f of x plus h is square root of x plus h. So this is square root of x plus h. This one is the function itself, and h doesn't change. Now, the technique to fix the problem here, to simplify the problem, is to multiply by the conjugate of the numerator. This is what's coming up later on, so I want to explain that to you. Because ultimately, in later math courses, h will approach 0, and it will never get to 0, but you take the limit when h goes to 0, and you want to eliminate that. The process is to multiply this by the conjugate of this one. Recall the conjugate of a minus b is a plus b, and their product is a squared minus b squared. So all you have to do, change this to a plus sign. But you can't just multiply by it. Also, you have to divide by it. This expression, everybody, is equal to 1. It's important to understand this. This expression is equal to 1. So you are not changing the essence of the original fraction. So what happens, you keep the denominator intact as a product of h and square root of x plus h plus square root of x. And now the numerator, let me just erase and show you what we are going to do. We are going to multiply these two, and therefore the first one comes out as follows: square root of x plus h quantity squared minus square root of x quantity squared, because as I mentioned, a minus b and a plus b, everybody remembers the product is a squared minus b squared, and therefore we get the following. Clearly, x and minus x cancel each other. The numerator remains with h and h only. It can cancel the h in the denominator. When you cancel it, you replace it with 1, and the final answer is 1 over the square root of x plus h plus square root of x. So you are rationalizing the numerator in this case, okay? Library of functions, one of those functions, f of x squared of x, we are looking at elementary functions, essential functions, or library of functions. That means the same thing, everybody. So we want to graph this, and we start with just plotting points. When x is 0, the answer is 0. 1 gives you 1, 4 gives you 2, 9 gives you 3, 16 gives you 4. If you use other numbers, you need a calculator. So then you write them as pairs: 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. And if you plot those pairs carefully, it looks something like that. So you should remember the graph, the general shape, everybody, okay? This one or this one, okay? Now, we want to discuss the intercepts. The x-intercept and the y-intercept are the same, located at 0, 0. So 0, 0 is both. Domain, all possible x values, everything to the right of 0, including 0, so it's 0 to infinity. And the range, all the y coordinates, again, above the x-axis, so the same thing from 0 to infinity. So please understand, this would be the domain, this would be the range, both of them 0 to infinity. the concept of a symmetry, even, odd, and I'm going to say that the function is neither even nor odd. It has no symmetry. Why is that? Reminding you of the following. When we say an even function, we can show it's even by evaluating f of minus x, if f of minus x equals f of x. It's odd function if evaluation of f of minus x results in minus f of x. And when we plug in minus x, we get square root of minus x. This is neither equal to f of x, so it's not equal to square root of x, nor equal to the negative of that minus square root of x. So this proves that it's neither nor. Is this function increasing or decreasing? Look at the function. The function is increasing. Remember, when x gets larger, so y gets larger. So where is it increasing or it's increasing everywhere in the entire domain. We don't include the endpoint, the very endpoint. What is it? We don't know. We don't care. So remember, increasing in short means this class. If you recall, this means when x gets larger, so does y. Okay. Maximum and minimum value. If you look at this point, having coordinates 0, 0, so the absolute minimum is equal to 0 at 0, 0. Again, I want to make sure you understand the way we write this. When we refer to max and mean, we are referring to the y coordinate. The y coordinate is 0 at this pair, and this is the location. There is no other point that has a smaller y coordinate. So one of those functions is a basic elementary function f of x equals square root of x. One of them is cube root of x. So we're going to look at this case now. And again, we start with some x coordinates. We're going to go with easy ones, class, the ones that they don't need the use of calculus, because we know cube root of minus 8 is minus 2, cube root of minus 1 is minus 1, 0 gives you 0, 1 gives you 1, 8 gives you 2, 27 gives you 3. Those are easy numbers. If you use other numbers, then you have to use a calculator. Let's write them as a pairs. And if you plot them carefully, it looks something like this. Now, of course, if you have a number such as 2, then cube root of 2. Okay. If you have a number such as negative 1 over 8, becomes minus 1/2. If you have negative 2 minus cube root of 2. It's important to know, in the case of an odd index, negative comes out as negative. If you have a negative number, comes out as negative. You have a positive number, comes out as a positive. Let's discuss this important information, starting with the intercepts. As you can see, 0, 0 is both the x and y intercept. Domain and range. Domain means all possible values of x. As you can see, the graph covers all the x-axis, all real numbers, negative to positive infinity. The range would be all possible values of y, and this continues indefinitely. It goes up, the same thing goes down, and it covers the entire y-axis. So the same thing, negative to positive infinity. Is it even, odd, any of those? And the function is odd and symmetric with respect to the origin. Why is that? Let's evaluate f of minus x. Let's replace the x with minus x. What do we get? Let me quickly show you that if I go with that, f of minus x becomes cube root of minus x. And as I mentioned, I can take the negative out, because cube root of negative 1, we should know it's negative 1. So minus square root of x which makes it negative of f of x. In that case, it is symmetric with respect to the origin. Now, what it means is that if you pick any pair and if you draw a line segment to the origin, if you continue, it gives you another pair on the graph. Pick any point, this point, and cover it. And if you go the same distance, okay? So pick any point. If I pick this point, this distance is the same as this distance. Let me use a different color. If I continue the same distance, then I get another point on the graph. That's the idea of a symmetry. Is this increasing? Is this decreasing? I hope you see that you recognize it's decreasing everywhere from negative to positive infinity. Do we have a max and mean? We don't have a max and mean. Max and mean, you have to pinpoint a number. When x becomes large, so does y. X goes to infinity, y goes to infinity. When x becomes small, y becomes small. X goes to negative infinity, y goes to negative infinity. The concept of the end behavior of a function. Another elementary function would be absolute value of x. And absolute value of x by definition means distance from 0, which means absolute value of x is equal to x if x is larger than or equal to 0 minus x if x is less than 0. So if you were to graph this and again pick up a few pairs and you put it in here, whether it's negative or positive makes it positive. So negative 2 gives you 2, negative 1 gives you 1, 0 is 0, 1 is 1, 2 is 2, 3 is 3. And those are the pairs. If you graph this, it will look like a V shape, everybody. Looks like a V shape. Discuss the intercepts. Well, we have 0, 0, which is both x as well as y intercept. Domain. What does this graph cover along the x-axis? I hope you see this part covers this portion, this part covers this portion from negative to positive infinity. That would be the domain. What about the range? This part and this part, both of them just cover the positive side. So from 0 to infinity, and 0 is included. That's why we have a bracket. Symmetry, even, odd. Well, let's work it out to see what we get. We basically evaluate f of minus x. It gives you absolute value of minus x, which is the same as absolute value of x, which makes it the same as f of x, which means it's an even function. The function is even and symmetric WRT with respect to the y-axis. Notice the right side and the left side of y-axis, they are identical. So it's symmetric with respect to the y-axis. Clearly, you can see it from the graph also. Is this function decreasing, increasing? Where is that? And so on. So you can clearly see the function is decreasing here. So from negative, so along the x-axis, from negative infinity to 0, it's decreasing. And it's increasing on the right side of 0, right? As x gets larger, y gets larger. So that is from 0 to infinity. Max and mean. This is the location of a minimum. So minimum equals minimum equals 0 at the pair 0, comma 0. So we have an absolute mean at that location. Absolute mean at 0, 0. So this is the location. Sometimes they say just at x equals 0. The minimum value refers to the y coordinate. The y coordinate happen to be the same as the x coordinate for this case. So the minimum equals 0 at 0, comma 0. So the library of the function, one of them is a constant function where f of x equals b. That means just any number. Y equals 5, 2, 1. It's a horizontal line which has a no x-intercept, y-intercept of 0, b, and the domain is all real numbers, and the range is 1 point b. We have f of x or y equals x, a line that goes through the origin, and the domain and range are all real numbers. Identity function, we call it y equals x or f of x equals x. Square function, f of x equals x squared, looks like that. It's a parabola. Domain is all real numbers, ranges from 0 to infinity. We have the cube function, f of x equals x cubed. Domain and range are all real numbers. We looked at the square root function, f of x equals square root of x and cube root of x. We discussed the details. So square root function, cube root function, and we also have a reciprocal function, f of x or y equals 1 over x, which has a shape like that, and it has a vertical asymptote and a horizontal asymptote. And some of you may remember that. We'll discuss it, of course, with more details later on. So this is known as the library of functions. Okay. So just to add a couple of things here. So domain is all real numbers. Range is just p. Domain and range, both of them is negative to positive infinity. Okay. In this case, domain is from 0 to infinity. A domain is from negative infinity to infinity. Range is from 0 to infinity, so minus infinity to infinity, and the range is from 0 to infinity. This one, domain and range, is all real numbers, minus to positive infinity. The square root function, cube root functions have been discussed. The reciprocal, domain and range, they exclude 0. So domain for this one would be minus infinity to 0, union 0 to infinity. That means all x values instead of except 0. The range works out to be the same, minus infinity, 0, union 0 to infinity, all y coordinates except 0. Okay, so that's the meaning of it. We have a function called the greatest integer function. We use double bracket to represent that. And by definition, it means greatest integer less than or equal to x. That's just the definition of this function. It's sometimes they call it a step function. Okay. And so the greatest integer function is defined as the function that provides the greatest integer less than or equal to a given number, denoted as double brackets x, okay, open and closed, where x is the input number. It returns the largest integer that is not greater than x. So, for example, if we look at these numbers, okay, first I want to discuss the integers. So -1 gives you -1, 0 gives you 0, 1 gives you 1, 10 gives you 10. Any integer returns the integer. But when it's not an integer, that makes it interesting. So for example, -1/2, okay? Remember, the greatest integer less than or equal to x. Your x is this. So the integer which is less than that is -1. The integer which is less than that is -1. This is 0. Now 1/4. The integer less than that is 0. The integer less than 1/2 is 0. The integer less than 3/4 is 0. As an example, if I had, let's say, 5/3, the integer less than that would be 1. Okay, so these are the pairs that we get for each case. If we graph them, it looks like what you see, and therefore it's called a step function because it looks like a step. So for example, what does that mean? If you look at just this part, it means if you pick a number, 0 gives you 0, and any number between 0 and 1 results in 0 as long as it's not hitting 1. The moment you hit 1, 1 gives you 1. And any number between 1 and 2 is equal to 1, except 2 is equal to 2. Any number between 2 and 3 is equal to 2, except 3, which is equal to 3, so on and so forth. That's the meaning of the greatest integer function. You come across them sometimes. They have applications. Vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph doesn't represent a function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. We've discussed this before. So here's an example. Here's another example. Both of them are functions. Here's another example, which is not a function. So take a look. This is a function. This is a function, but this is not. The reason is very simple. There is no way we can come up with a point, okay, with that this vertical line crosses the graph more than once. The same here, but over here, it crosses it at these 2 points. Do you see that? So therefore, it is not a function. Same thing here. I mean, you don't even have to draw a vertical line. This y-axis acts like a vertical line, and right here there are 2 points, so it fails to be a function. This happened to be x equals y squared minus 2. You may remember it from intermediate algebra. Shown is not the graph of a function of x. It's not a function. The parabola in this case, however, does contain the graph of 2 functions of x. We're talking about this one. If you cut it into 2 pieces, the top piece and the bottom piece, class. The top piece, if you solve for y, let me show you. If you solve for y, so I'm going to move this way, and I'm going to get x plus 2 equals y squared, and then y is plus minus the square root of x plus 2. So the top one is the plus 1, and that is a function. And y equals minus square root of x plus 2 is the bottom half. So this cuts the top, this cuts it into 2 halves, the top half and the bottom half. Both of them are functions. So the parabola, however, does contain the graph of 2 functions of x. Okay, this one and this one. So in other words, there is a way to fix the problem. For each graph, determine the domain and range, then state whether each relation is a function. So when we look at this one, the domain, so basically you start from here and you go to infinity. So from 1 to infinity, so from here, going this way. That would be the domain. As far as the range is concerned, this portion covers all the y-axis above the x-axis, and this portion covers all of this, so all real numbers or negative to positive infinity. Is this a function? No, it fails the vertical line test. You see that? Therefore, no, it's not a function. For this one, you remember the domain is all real numbers because this portion covers the right side of x, this portion covers the left side. So all real numbers or negative to positive infinity. As far as the range is concerned, anything from here, -1 to infinity, and we write it bracket -1 to infinity, or we write y is larger than or equal to -1. And yes, it does represent a function because no vertical line can cross the graph more than once. So yes, it's a function. Which of the following are graphs of functions? This one is a function, this one is a function, this is not a function, this is not a function. Clearly, by looking at a vertical line test, you see these two do pass a vertical line test. This one clearly fails the vertical line test, and this one clearly fails. Therefore, the first two represent functions and the last two don't. Yes, yes, no, no. Use the graph to find the value of the function at those points. So f of 4, so locate the x equals 4, the y coordinate is 0, therefore you're going to write when x is 4, y is 0, or f of 4 equal to 0. You don't have to write, you can just write f of 4 equals 0. F of 6, locate the 6 along the x-axis, and on the graph is this point, seems to have a y coordinate of 1.5. So we write when x is 6, y2 seem to be 1.5, and therefore f of 6 is 1.5. What about f of 8? You look at 8 and it gives you this point. And this point has a y coordinate 2, and that's your answer. So when x is 8, y is 2, therefore f of 8 is 2. Pretty straightforward. Use the graph to find the domain and range. Well, here's the domain, everybody. Anything that we cover along the x-axis by the graph is the domain. Therefore, we go from 0 to 7 along the x-axis. Anything that we cover along the y-axis. Now, the bottom here covers here, the top here covers here. So we go anywhere from here to there, which is -2 to 4 along the y-axis. Therefore, the range, bracket -2, comma 4 bracket, close bracket. This is how you recognize the domain and range. A function is 1-to-1. We write it this way or that way. If each element in the range corresponds to exactly one element in the domain. Horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a 1-to-1 function. So here's the function. Because it passes the vertical line test. However, it fails the horizontal line test. It's not a 1-to-1 function. And if you cut it in half, make up two pieces, this portion is a one-to-one function, the left side also. And so if function f is one-to-one, if for any two numbers a and b in its domain, if f of a equals to f of b, that indicates that a must be b, and when a is not equal to b, f of a is not equal to f of b. In short, a function refers to a graph where x does not repeat. Now, a one-to-one function, not only the x doesn't repeat, the y doesn't repeat either. So none of the variables, the first or the second coordinates, cannot repeat. That's the shortest way to think about it. For example, are the following sets functions, one-to-one functions? What are they? So that's what we are going to look at quickly. And so if you look at both of them, look at the first one, 1, 3, 4, -2. They're all different. Look at the second one, 1, 3, 4, -2. So both of them represent a function. So both sets A and B represent functions since each x coordinate corresponds to exactly one y coordinate. Let's look at the y coordinates. If you look at the y coordinate 2, 5, 6, 1, they don't repeat. So A is also a one-to-one function. If you look at B, 2, 5, 6, 5, look at this one. This y coordinate, and this y coordinate are the same. So A is a one-to-one function, B is not. So set A is also a one-to-one function since each y coordinate also corresponds to exactly one x coordinate. However, set B is not a one-to-one function since the y coordinate 5 corresponds to two x coordinates, 3 and 2, and -2. 3 and -2.